Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to everyone who is watching. Acap, Yusuf, Alhamdulillah. Can you guys hear me? Iman, is my voice clear to be heard? If yes, you can comment in the section. Hope you guys are doing well. Few more hours, we'll be entering Ramadan, the month of Ramadan. Allahumma balighna Ramadan. So we will be starting with our Tarawih prayers. Hopefully the Imam here in this Facebook Live, you guys, referring to you guys, yeah, you guys are going to be Imam, inshallah. Hopefully you have already revised the verses to be read, inshallah. Sebut saya Imam Tarawih terus semua senyap, tak berani. Okay, dah habis SPM, tinggal sikit lagi nak pergi overseas tahun depan, insyaAllah. So kena jadi imam. Kelas rep, kelas pun boleh jadi representative, imam for sure no problem. Yes, Alhamdulillah. So we'll wait a few more minutes. Agak lewat sikit hari ni, tengah hari kan. Hopefully our connection this afternoon is clear. So sekarang ni dekat Bangi, where I'm at right now, Bangi, hujan lebat. Oh, mantap, mantul. Okay, 14 orang. Sikit lagi. To those of you who have filled in my survey form, thank you very much. I really appreciate the feedback that you've been given me. So tapi tak semua yang fill up. I would really appreciate if you do so. The link is available dalam Telegram group. Almost 70% of you fill in the survey form. Ada lagi yang tak sempat nak isi. Mungkin tak perasan ada link tu kan, sebab banyak sangat benda. Petang ni ada kelas lagi after 4, 4 sampai 5. Alhamdulillah. So boleh relax, prepare untuk Ramadan. Maghrib, Isya. May Allah bless us in this holy month, insyaAllah. Few more hours. Still, we do not know what will going to happen. Just increase our prayers. Tadi ada 14, sekarang tinggal 13 orang. Dari 15 dah, Alhamdulillah. So I assume that we can start straight away lah, insyaAllah. So we are 6 minutes in. So siapa yang nak refer kepada group ni, lepas 6 minit boleh chat balik. Okay, insyaAllah we'll start with kitab Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Ar-Rahmanirrahim. Maliki yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Alright, so we are in chapter 10 on electric fields. 2 more chapters and we are done with the syllabus for AS. Then we will be proceeding straight away to A2 syllabus. But for the assessment of your first part, which is AS, it is only until this chapter 12. Okay, chapter 12. Right, so cut it short, straight away to the questions. You can actually refer to the first video where I've actually discussed on the same questions. So hopefully the session for today, Waalaikumsalam warahmatullahi wabarakatuh. Welcome Hana Sufyan, inshallah, with a wavy hand. So where was I just now? They are the questions. So hopefully the discussion this afternoon will be different somehow. Okay, hopefully. Depends. Okay, so in the tutorial there are basically 2 main conceptual ataupun soalan definisi lah. Here we have the definition of an electric field. The next question is going to be the definition of an electric field strength. So without the strength is only an electric field. So the field itself, we want to define what is an electric field. So it is basically a region or a region of space where a stationary charge, either positive or negative, experiences a force where we call it an electric force. Okay, quite straightforward, isn't it? Now moving on. The electric field between an earthed metal plate and 2 charged metal spheres is illustrated in figure 5.1, although it does not state how the metal spheres are charged. Okay, so here in between these 2 metal spheres, charged metal spheres, they placed an earthed metal plate here just to attract. So this is an example of an electric field. We are required to label each sphere positive and negative to show its charge. So yang ni memang very basic punya electric lah . Positive goes to negative. Positive dia keluar, maknanya dia melihat keluar. Kalau negatif dia melihat ke dalam. So positive and negative, they attract each other. Same signs would repel each other. So the profile is provided in the notes. Straightforward. On figure 5.1, mark a region where the magnitude of the electric field is constant and is decreasing. So you label it with C and D. So here, one thing to note, when we want to define the electric field, which is the first part of this chapter lah kan, 10.1, the strength of the electric field is actually indicated by the closeness of the lines, where closer lines will indicate a stronger field, and further lines will indicate a weaker field. So here we can observe close to the source, close to the source, the lines are actually close to each other. So that indicates a strong electric field somewhere near the sources, which is the charge sphere lah. Even kat sini pun sama. Kalau kita nak tengok pada magnitude lah kan. So kalau kat sini, dekat tengah-tengah metal plate kira would be the minimum amount of electric field strength lah. Somewhere in the middle. It is not uniform. Kalau dia uniform, maknanya the lines would be straight away, kan? Kalau you have a two parallel plates, then we will have a uniform electric field somewhere in the middle, not on the side, sebab kalau side nanti dia curved, kan? So kalau kat sini dia hanya dia tak uniform lah, kan? So there is a decrease and increase, and there is actually one area yang dia akan jadi constant. So we need to label this area. So this region of constant magnitude of the electric field is actually defined somewhere in the middle, in between the two spheres. So kalau dalam schematic answer tu dia just kata 5 millimeters of the plate, somewhere in the middle. Kalau kat tengah-tengah tu kita define it as 10 millimeters. Okay, maksud dia apa? Somewhere in the middle kat sini kita nampak the lines top and bottom are arranged in parallel. There's no curve kat situ. Kalau curve maknanya dia tak uniform, maknanya dia tak constant. Kalau dia parallel daripada atas bawah tu, cantik je, kan, dia susunan tu. So that's where we have a constant magnitude of the electric field. And of course, kalau kat tengah-tengah ni, for sure lah dia lebih straight ataupun lebih parallel, kan. So that's why we have a constant tu dekat tengah-tengah, dia lebih sikit 10 millimeters. Kalau kat yang lain, the other points tu is when the electric field is actually touching the earth metal plate. So dia adalah small length where it is constant between each other. So if you label between those regions, you get that 1 point lah. Okay. What about decreasing? So decreasing is when the electric fields goes from being close and then they get further away. So this is the point where it get decrease, a decrease in electric field strength lah. Okay. So this is it, and this is the setup lah. Hopefully you guys have already attempted to do these questions before our live session today, so that we can engage in discussion. I gave the questions yesterday. I'm not sure perasan ke tak, sebab ada a few files kan yang saya hantar semalam, kan. Dua file ialah schematic answer untuk quiz chapter 9 part 1 dengan part 2, and then I gave you a link on my survey form, and as well a tutorial question. Ke saya tak bagi ke tutorial question? Not sure, tak ingat. Sepatutnya bagi. Ada ke bagi? Kena check dalam Telegram. Alright. Part C here, a molecule has its center P of positive charge situated a distance of 2.8 times 10 to the power minus 10. Okay, memang ada, thanks Kalisha. From its center N of negative charge. So dia ada positive charge here, negative charge here, as illustrated in figure 5.2. Alright. The molecule is situated in a uniform electric field of field strength 5 times 10 to the power 4 volts per meter. Kat sini dia ada electric field strength. The units used here is volt per meter, and we know that there is another representation of units for electric field strength, which is newtons per column. Newtons per column, NC-1, isn't it? Because electric field strength, dia ada dua main formula yang kita gunakan throughout the chapter, kan, which akan guna juga waktu-waktu lain juga, kan, which is E is equals to F over Q, and E is equals to V over D, where both are interchangeable actually. But here it states that the electric field strength is 5 times 10 to the power 4 volts per meter. The axis NP of the molecule is at an angle of 30 degrees to this uniform applied electric field. Somehow, probably why is it distorted? Mungkin because actually it is actually in parallel ataupun perpendicular or whatnot, tapi because of the applied electric field, so the molecules actually move. Is it possible for them to move? Yes, it is. Because when you apply something, then dia ada motion kat situ. Probably what we have here is actually a snapshot of when the molecules are stationary. So the magnitude of the charge at P and at N is 1.6 times 10 to the power of minus 19. So basically we can say that the magnitude of the charge throughout is actually uniform atau constant at that value. Okay. So dia kata on figure 5.2, draw an arrow at P and an arrow at N to show the directions of the forces due to the applied electric field at each of these points. So we are given P as positive source, isn't it? Point source positive for the molecule, and then we got N as negative. So dia tak buat confusing lah. Dia tak terbalikkan P ialah N negative, N ialah positive and whatnot. Okay, P ialah positive, N ialah negative. So the direction of the electric field is given as this, from left to right. So we know by definition, positive is going outwards, negative is going inwards. When you become a very negative person, you will think that everything is wrong. The world is going to end. So you become very negative and you always look inside and you do not look forward. So if you are a positive person, always positive, you are always looking in front. You are always looking in the future. Tiba-tiba jadi futurist lah pula kan. Alright. So you've got a positive and negative side. So positive going to the negative side, they attract lah kan. Different signs will attract. So says here, draw an arrow at P. So we have to draw an arrow at P, and bearing in mind P is a positive source. So dia arah ke mana? Of course lah, dia positif dia akan arah kepada negatif. Kalau negatif dia tak akan pergi ke negatif. Negatif dia akan cari positif. So that untuk nak cancel out lah kan, neutral lah, something like that. So the direction will be like this. So here we can see that these are the red directions. Okay, negative going to positive, positive going to negative. Alright. Calculate the torque on the molecule produced by the forces in 1. Gitu. So what is the definition of torque? Torque is actually the force multiplied by the perpendicular distance between the acting force and the pivot. So that is the formal definition that you can always remember from your dynamics a long time ago. I think it was what? Chapter 5, chapter 4, forces, something like that. Okay, so we define the distance must be perpendicular. So that's where the degree, 30 degrees actually comes in lah kan. Okay, first we substitute where the force here is actually referring to the electric force, force caused by the electric field, where force is equals to QE. Definition of electric field strength tadi tu kan, E is equals to F over Q. So F is equals to QE. And then D perpendicular. So what is D perpendicular, what is Q, and what is E? So we look at the questions, the information or the data given is Q equals to 1.6 times 10 to the power minus 19, which is an elementary charge in coulombs. And then we've got the electric field strength, I've mentioned it just now, 50,000. And then D, okay, the value of the distance given here is not D perpendicular, but is actually the effective length between P and N. Now we want to know what is the perpendicular distance between the both of the point source with the electric field direction. So kita define D as 2.8 times 10 to the power minus 10, but D perpendicular is equals to D sine 30 degrees kat situ. Kan? So if we assign one point as a pivot, then we can get the torque. So kat situ kita akan tahu, plug into the values semua kan. Make sure conversion tak ada masalah, semua tak ada unit pelik-pelik millimeters apa semua, everything is all set, and you get the answer. The answer of the torque is equals to approximately 1.1 times 10 to the power minus 24 Newton meters, or 1.1 times 10 to the power minus 24 joules lah. Pun boleh. Tapi kita guna kat sini Newton meters. Alright, so that concludes question number 1. Question number 2. Okay, if we had the conceptual question of definition electric field just now, now we have electric field strength. So the schematic answer that we would use, the definition of an electric field strength is, at a point, is the force per unit charge acting on a small positive charge placed at that point. So E is equals to Fe over Q. Okay, straightforward. A uniform electric field is produced by applying a potential difference of 1200 volts. So yang ni kita tahu ialah V lah kan. Across two parallel metal plates in a vacuum, as shown in figure 4.1. The separation of the plates is 14 millimeters. A particle P with charge 3.2 times 10 to the power minus 19 coulombs and mass 6.6 times 10 to the power minus 27 kilograms starts from rest at the lower plate and is moved vertically to the top plate by the electric field. So kat sini kita tahu electric field kat sini menggerakkan this particular particle P with mass M 6.6 times 10 to the minus 27. What do you think? Is this a proton or is this an electron with given this type of mass value? Answer in the comments below. So dia kata electric field ni menggerakkan P from this metal plate, from the bottom metal plate going upwards kat sini. Alright. So that's the force. Now what we are required to do, calculate first the electric field strength between the plates. So the electric field strength, we are given V, we know D, so no problem, E equals to V over D. You just have to memorize the formula because the formula is not given. So the value of E is approximately 8.6 times 10 to the power 4 volts per meter. Alright. Now, if you observe the next question, the work done on P by the electric field. So this configuration is not similar to the one that is provided in the videos, if I'm not mistaken. Because kalau dalam video tu dia daripada atas dia turunkan ke bawah, cuma yang ni dia daripada bawah ke atas. Beza kan? So okay, most of you think it is a proton. Acceptable because roughly the magnitude of the mass is actually of a proton is approximately 10 to the power of minus 27 sebenarnya. Okay, the work done by P on P by the electric field. So if it is moving from the bottom plate to the top plate, assuming that it is a proton, see, you rasa dia proton sebab dia punya mass 10 to the power of minus 27 ke ataupun sebab label dia P? Saja je. Okay, the work done moving this particle upwards, dia naik atas. So what we do, tengok kat sini, yeah. So we've got a positive on the bottom plate and negative on the top plate. So ada work done, okay, the work done by the electric field. So how do we know what is the work done by the electric field? So basically we can use this formula that you need to understand, you need to memorize juga. W is equals to QV, where V is actually equals to DE, sama juga lah kan. So W equals to QED pun boleh. You will get, eventually you get the same answer. So Q ni apa? Q is the value of the charge, and the charge 3.2 times 10 to the power minus 19 coulombs. So dia kata starts from rest. So P is actually resting, the initial velocity is 0 and goes up with a certain velocity yang kita boleh tahu by conservation of energy. The poll question that you answered in the Telegram group, tapi tak semua answer. I'm not sure why. Sebab dia bukannya calculation question kan. Kalau macam sebelum ni calculation question, so mungkin sebab tu salah ataupun tak jawab kan. Tapi yang ni bukan calculation question tapi tak semua jawab juga. So macam mana tu? Okay, again, so okay lah kot. So the work done, W equals to QV, straightforward. So substitute the values and you get V sama dengan 1200. Kalau you nak substitute V sama dengan DE pun, you eventually get the same answer kan sebenarnya. Okay, but because we are given the potential difference 1200 volts, so use it straight away. So now, when this particle P, it's a proton, when this particle P moves from the bottom plate to the top plate, that is a distance of 40 millimeters, and we know the mass is 6.6. What is the gain in gravitational potential energy of P? This is the question. So you have to recall the formula that you have studied during SPM and also during the early chapters in physics A levels. where the potential energy is actually given as mgh. So here kat sini dia kata the gain, because dia increase in the position. Okay, so delta U is equals to mg delta h. So m is given, g is also known, 9.81 meters per second squared, and the h is 14 millimeters. So this is where you can get trapped by the unit conversion. Always remember to convert it from millimeters to meters. So it's 10 to the power minus 3 dia bukan 10 to the power of minus 6, 10 to the power of minus 2, it's 10 to the power of minus 3. You know who you are. If I'm referring siapa yang selalu buat kesilapan teknikal dalam conversion. Okay, so ada quiz quiz untuk electric field. InsyaAllah it's not really that tough lah kot rasanya. Yelah, chapter 10 kan, masih lagi okay lah kan, still manageable I think, insyaAllah. The first day of Ramadan and you will get your first quiz on chapter 10. Young Talent Program, insyaAllah. So the answer is 9.06 times 10 to the power of minus 28 joules. Alright. So now what about the gain in kinetic energy of P? So the conservation of energy here, one would say that the gain in kinetic energy would be actually equals to the gain in the potential energy, betul tak? But that only applies if you are what? You are dropping the particle from the top plate to the down plate, betul tak? Sebab dia ada potential energy, lepas tu dia ada reduce in potential energy, and then it is converted into kinetic energy. But here it is different, because kalau you drop, that means the work done ialah the potential energy sahaja kan. Cuma this one is going up. Benda ni dia kita tengah naikkan benda tu ke atas. So the work done in order to move this particle going up is what? How do you calculate it? So we know the value of work done is equals to W equals to QV. The gain in potential energy is the value in part number 3. So in order to determine the kinetic energy is actually the difference. The difference between the work done and the kinetic energy there. So delta K is equals to W minus delta U. Yeah, that's why. So it's a different setting. Main daripada bawah pergi ke atas. So dia nak naik ke atas tu. So dia akan gain potential energy kat situ. So the work done tu dia termasuklah dengan kinetic energy and potential energy kat situ. So kalau ikutkan dia punya gain in potential energy tu sangat sikit lah kan. Kalau bandingkan dengan dia punya kinetic energy. So to observe this, actually if we refer to the velocity, the speed, laju lah kan? Betul lah kan, dia punya proton tu memanglah kena bergerak laju betul-betul kan. Kalau tak, because this one is very small kan, protons and electrons, benda yang kita kena beriman benda tu wujud walaupun kita tak nampak dengan mata kasar. So substitute kinetic energy formula, half mv squared, V is equals to 3.4 times 10 to the power of 5 meters per second. Voila. Okay, I said 2 questions on electric fields. Now it's 2:45. Spend half an hour approximately. Any questions? Anything you are unsure about? You can ask in the comment section. So if everything is okay, then give me a like or give me a heart. We'll proceed to the just 2 more slides, inshallah. Alright. So tips, not to say tips lah, lebih kepada satu Okay, there is a question. Farah Ardiana Sofia. Bit unclear on how to find the perpendicular distance on the previous question. Alright. It's quite straightforward. Don't worry. Tak ada yang benda yang susah dalam hidup ni, insyaAllah. Perpendicular distance ni dia lebih pada main dengan trigonometry lah. Okay. Main dengan trigonometry. Kita ada dia punya electric field, which is the horizontal line. Okay. Horizontal line. And then we've got the distance between P and N here, where the distance between P and N is given as this one, and it is not either perpendicular horizontal ataupun vertical. So what is the perpendicular distance? So perpendicular distance ni ialah perpendicular distance is with respect to what? Okay, so we have to find the perpendicular distance with respect to the electric field direction. So electric field dia, direction dia ialah horizontal. So kita nak tahu dia punya vertical. So vertical tu macam mana? If you see here that we can see a right kita panggil apa? Right angle triangle. Right angle triangle here. So we are given the hypotenuse, and we want to know what is the opposite value of this particular angle 30 degrees kat sini. Okay. So let me just color it with a blue pen. So here, this angle, katakanlah kita nak ambil pivot dia dekat P lah kan, dia boleh jadi P atau boleh jadi N, because yang ni parallel, this is 30 degrees theta, so here would also be 30 degrees juga lah. So we are given this distance 2.8 kan. So right angle triangle. Right angle triangle. So right angle triangle. Segitiga apa? Lupa dah. 90 degrees here. So this one is 60 degrees, tapi kita tak kisah. So if you are given this hypotenuse, this distance would be sin 30. Kan kalau sin dia opposite bagi hypotenuse kan. So we want to find out the opposite here. So this one is equal to D, hypotenuse, multiplied by sin 30 degrees. Okay. So hopefully that answers your question. If okay, thumbs up. Ataupun just say okay. Oh ya, okay pun. Okay juga. Segitiga tepat. Asalkan bukan segitiga Illuminati. Alright. Okay, next question. I don't understand why the C is 10 millimeters of central part of plate. Okay. Why is C 10 millimeters apart of the plate? Okay. So, okay, yang ni mungkin dia punya figure ni tak tepat sangat 10 millimeters tu kat central 10 millimeters kat central. Why? Because if you observe near the central for 10 millimeters ni kat mana? Sini this is 10 millimeters. This is 10 millimeters. Okay, 10 millimeters kat sini. Maknanya apa? If you observe carefully, the lines are somewhat parallel near the center. Betul tak? Tapi kalau kat atas ni, dia dah curve. You can see a curve kat sini. So that's why we only take, kalau you nak label C tu dekat tengah-tengah ni, make sure it is within the 10 millimeter distance 10 millimeter ni sebenarnya ialah untuk invigilators maknanya orang yang mark paper. So dia kena ukur dengan pembaris, okay, 10 millimeter, tak boleh lebih 10 millimeter. Kalau letak 11 millimeter, you penalized, so tak dapat markah. So it's just a guide for them. Okay, kita tak perlu untuk nak cakap is 10 millimeters, no, just approximately to you have to label where the region in which the lines are almost parallel. Sebab kalau not in the center, dia akan jadi curve. So kalau curve, it's not constant lah, kan, it's not constant. So tapi kalau dia somewhere, so sebab tu dia kata kalau nak ambil daripada 5 millimeters tu, maknanya sebab kalau tengok 5 millimeters, for an earth metal plate, the electric field lines when entering ataupun bila nak bersentuhan dengan earth metal plate tu, dia akan jadi straight. dia akan jadi straight. So yang tu throughout the metal plate lah kan. Okay, hopefully that answers the question. So dia kata 10 millimeters of central part of plate, 5 millimeters of plate where the lines are straight. So 10 millimeters kalau central part, this is the central part. 5 millimeters somewhere along the plate lah. Nak bagi. Okay. Alright, you are welcome. So now, just as a overview, hopefully, sebab ada saya dapat feedback daripada you all punya notes, ada yang mengatakan electric field ni ialah one of the toughest part in physics. Probably because it plays with something that is abstract and you cannot observe with your naked eye. Comparing to forces, main dengan inclined plane, or you play with your string, wave pun kalau ikut kan tak nampak juga particles kan, tapi kita nampak lah benda tu bergerak kan. Cuma electric field ni dia macam when you switch on the light, then the bulb will appear kan, dia akan menyala kan. Mengujilah akidah kita kan, keimanan kita jugalah kan, whether does the electric electrons actually exist. Contohnya macam tu kan. So biasalah kan, disebabkan kita punya keimanan kepada benda-benda yang gaib ni tinggi, so kita percaya sajalah. Cuma ya, mungkin disebabkan keimanan kita tu tak berapa kuat sangat, so we cannot embrace this chapter. So sebab tu dia macam payah. So I get a lot of feedback notes you all yang saya tak komen lagi kan. Jenuh juga sebenarnya nak komen satu-satu, tapi saya just dah baca dah semua. Nak komen tu saya just sebab tu nak buat this session, so komen overall. Benda ni memang abstract, melibatkan beriman dengan perkara-perkara yang kita nampak, but it is there kan. So one way for us to actually mungkin lah untuk nak help you guys, untuk nak ingat, probably is for us to kumpulkan semua related formulas for that chapter. Maknanya this is what I'm going to do lah. So for example, for this chapter 10 electric fields, we've got I'm just give apa kita panggil lah, summary. Okay, a summary. Yalah sebab you all pun terpaksa tengok video. Sebenarnya tengok video antara tengok video dengan live lecture. Kalau live lecture dia tak ada rakaman kan. So dia macam it all depends on that particular live lecture. Maksudnya live lecture maksud saya dekat college lah kan. Kalau college tak ada siapa ambil video, so you tak tahulah habis the kelas tu. Mungkin tak ingat, tapi kalau dalam video ni you boleh tengok banyak kali, ulang banyak kali kan. Dengan syarat you tak klik thumbnail yang lain lah kan. Tiba-tiba dah habis tu tengok, scroll dekat sebelah kan, related videos kan. Related videos yang tak related sangat pun, klik juga lah last. Habis 3 jam kat situ kan. So dia ada challenge dia kat situ jugalah kan. So dia ada pros and cons. Tapi nak ceritanya, this is the summary that we try to do for every chapter. Ini chapter 10, 11 and 12. Sebenarnya benda ni pun you all boleh buat secara sendiri kan. Either macam saya suggest just now in the previous group, you can actually tak semestinya kena group 1.1 atau group 1.2 buat separate. You can actually tiga group tu cuba untuk nak buat a summary of list of ataupun tabulate all the list of formulas that you need to memorize. Sebab dalam question paper dah ada formula-formula tu juga, cumanya ada yang tak ada yang you kena memorize kan. So what is it that you need to memorize? Macam kalau nak fikir pemikiran kapitalis, seorang buat lepas tu dia jual dekat orang lain lah kan. Tapi tak sempat dia nak jual, dia jual kat seorang tu photostat, lepas tu dia jual, dia markup harga, tu cerita lain lah kan. Tapi it can be a collective effort from the 3 groups of you guys untuk nak come out with your formula sheet. Contoh boleh buat ALFT11 formula sheet for physics for example. This just to throw this idea to you. Well, it all depends on whether you want to do it or not lah. Cuma ya, for this chapter saja, the related data that might be important is actually the values of elementary charge E, which is given as 1.6 times 10 to the power minus 19. And the rest mass of electron minus 31, 9.11 times 10 to the power minus 31, ataupun approximately 1 kali 10 kuasa negatif 30. But you stick with this value lah kan. And then we've got the rest mass of proton, 1.67 times 10 to the power of minus 27. Yang kalau ingat soalan tadi yang P particle tu, roughly around the same magnitude lah kan, 10 to the minus 27 kat situ. So well, these formulas are actually provided in the question paper, so you don't have to worry about it lah. Cumanya kalau untuk quiz esok dia tak provide lah, so you have to know lah. Okay, so that's why I'm telling you right now. So, and then the related formula for this chapter, kalau ikutkan untuk nak bagi you semangat sikit lah, tak banyak, ada 3 je. Work done on a charge by an electric field, W is equal to QV, where the unit is joules. Senang kan? And then the electric field strength ada 2. Two definition juga lah kan. So ada volts per meter ataupun Newton per coulomb. So it's actually V over D ataupun Fe over Q, where Fe is the electric force. So itu je. Tak ada masalah. Kan? Simple je. Cumanya formula-formula chapter-chapter sebelum ni you kena faham lah. Like what I said in the previous video, macam potential energy, kinetic energy, the formulas of motion, Newton motion, S equals to UT plus KFT squared, V squared equals to U squared plus 2AS and whatnot. Itu semua yang you kena tahu pula kan. Cuma ya, mungkin formula-formula yang baru in this chapter, ini saja. So kita tambah sikit kat situ. Okay? Boleh ke? InsyaAllah. Semua talented students. InsyaAllah, I have complete faith in you. Okay, any other questions before we move on for the bonus slides, insyaAllah? Alright, moving on. Bonus slide, my present to you. Okay. So bonus slide ni dia bermanfaat jugalah. You will recall previous chapters punya laws and theories, insyaAllah. Recall in chapter 06, okay, work, energy and power, which is relating to principle of conservation of energy, alright, where you've got a ton of formulas, isn't it? Work, energy and power, P equals to FV and whatnot. So there is one particular principle that is important, which is the principle of conservation of energy, where it states, based on the polling, kan, mungkin ada seorang je lah yang tersilap tekan, kan. And you cannot retract your answer, so very sorry. Tapi tak apa. So energy cannot be created or destroyed by us. Of course, energy is actually created by Allah Subhanahu Wa Taala. If you revisit the concept of Big Bang, okay, it can only be converted from one form to another. As we have seen just now, a conversion between work done, potential energy, and kinetic energy, thermal, and etc. So from here also rise the concept of efficiency ratio, if you can recall. Okay, if you can remember, where the efficiency ratio is actually the ratio between useful energy output from the system to the total energy input given into the system. So, yalah, efficiency is equals to output over input. But output is not the all of the entire energy that is being produced by the system ataupun produced by the system. Sebab kalau semua energy, kalau tak ada perkataan useful ni, kalau semua energy output, so the ratio will become 1 lah kan, because conservation of energy. Cumanya to ensure to evaluate the efficiency of a system, so we have to define what is the system and what is the intended useful energy output. The example that I gave in the previous video is an air conditioner. So an air conditioner actually gives out the thermal energy. So air conditioner, it can be a heater or a cold air conditioner lah kan. Kalau dekat overseas dulu, kereta semua dia ada dua temperature. Dia boleh naik, dia boleh turun kan. Sebab kalau winter kita nak naik, kita tak nak turun. Kalau summer kita nak naik macam kat Malaysia, bukannya kita nak turun. Kalau buka tingkap, dia jadi kering. So to condition the air, kita akan ada thermal energy. Tapi despite of having only useful energy output for a system, we also have useless energy output kan. Contohnya kalau dalam aircon, contoh yang sama, useless energy output ialah apa? Ialah bunyi. Bunyi ialah benda yang kita tak nak, tapi energy yang kita bawa bagi masuk dalam kita punya sistem tu, ni electrical lah kan, electrical energy bawa masuk dalam, tapi because ada inefficiency, so there are some amount atau percentage of energy that is converted into noise kan. So that's what we call loss, ataupun dia bergegar kan, aircon tu bergegar, so that means we have got a force kat situ. So those are actually the useless energy outputs, not desirable from the system. So that's why when we want to determine the efficiency of a system, we have to take the ratio of only the useful energy output. So itu definition of efficiency lah yang kita tahu by conservation of energy. So kat sini memang dia punya application banyak lah kan dekat electrical appliances kita. So macam kalau you guys pergi dekat your punya peti ais kan, pergi turun bawah, brand apa, Toshiba ke, LG ke, Sharp ke kan, you tengok kat tu ada tak lekat. Kalau tak lekat tu maknanya mungkin cetak rompak lah ciplak kan, tak approved by the Suruhanjaya Tenaga Malaysia. Tapi you will see this label kan. So this label ni very famous lah dekat TMB kan. The more number of stars, that means the more efficient your electrical appliance is. Kalau dia sikit, maknanya dia tak efficient. Maksudnya efficient tu mungkin dia jadi panas, benda yang tak efficient lah kan. Kalau contoh you punya peti ais tu, there will come a time when bila you buka tengok semua cair kan dalam peti ais tu. Sebab apa? Bukannya sebab hardware ke, sebab electrical connection dia tu tak smooth ke apa. Probably because of the getar dia je tu. The rubber that actually ensures that the air inside the refrigerator does not come out, for example. Only because of that, dia dah hilang dia punya elasticity, so they become very stiff. So the air inside the refrigerator cannot cool itself down. So kat situ dia akan jadi very inefficient. So semua barang-barang dalam peti ais tu semua akan mencair, if you observe lah. So maknanya walaupun they give berapa star dalam you punya peti ais tu, kadang-kadang ada external factors yang memang kita tak boleh nak kawal lah. Yang ni kita panggil wear and tear lah kan. Kalau dalam kereta pun dia ada sama juga, kita punya braking system. That is an example of a braking system. For an efficient braking system, the force we exert will convert directly to friction in order to stop the tires from moving kan, contohnya. Tapi kalau dia inefficient, contohnya ada dust, so dia terpaksa exert more work in order to stop the tire, contohnya kan. So ini very practical lah in life kan, efficiency, and people will always be researching in order to make things more efficient day by day. This physics lah, okay. Kalau kat luar negara dia adalah dia punya label kat sini, mungkin sebab orang Malaysia dia suka star ni kan, suka like apa semua kan. Tapi kalau kat luar tu, even kat Malaysia pun ada juga sebenarnya kan, SEER kan. So we have this spectrum, maknanya kalau dia hijau dia very efficient, so dia ada A+++++++++++++++++++++++++++++++++++++++++++++++++++++++++++++++++++++++ kalau D merah maknanya very inefficient system. So dia kita tak ada efficiency of you punya physics ataupun you punya A-level kan, ataupun SPM tak ada efficiency kan, dia lebih pada you punya magnitude berapa kan. So mungkin sebab tu dia dapat A+ ataupun A star saja kan. Kalau efficient tu maknanya apa efficient tu maknanya you belajar sikit, belajar sikit lepas tu result gempak macam tu. Is that considered as efficient? Okay, tak apa. Alright, so this bonus slide. So let me nak ajak semua, okay. I'd like to invite you guys, including myself, to ponder upon 2 verses of the Quran. Allah SWT says in Surah Ar-Rahman, and he repeats this verse multiple number of times. Dia kata, A'udzubillahi minasyaitonirrajim, fabiayyi ala'i rabbikuma tukadziban. Dia kata, so which of the favors, ala'i ataupun ni'mah of your Rabb would you deny? And it is repeated 31 times in the same chapter, Surah Ar-Rahman, Surah number 55 in the Juzu of 27. So, undeniably, we are given by Allah SWT ni'mah or favors, nikmat-nikmat orang Melayu kata kan, nikmat-nikmat yang sangat banyak Allah SWT bagi, consciously and subconsciously both. Examples of subconscious ni'mah that Allah SWT has given us that sometimes we take for granted is like what? Being able to breathe, inhaling and exhaling. Who enables us to breathe freely? It's actually Allah Subhanahu Wa Taala. Our lungs are being moved. You can explain it biologically, but at the end of the day, even like for example, I'm in the field of medical physics. Understanding the pacemaker is not really a perfect model of the human's heart. When kita main the beating heart, jantung. It's not really dia ada prone to inefficiency juga. Multiple factors, and not all of the material used in order to make the pacemaker is compatible with our human body. So we have given tons of favors and ni'mas. I won't be explaining further. You can check out my previous videos. This we can assume as input, the total input that Allah SWT has given us as a human being system, mankind, a system of mankind. But what worries us when Allah SWT says in another verse, very famous verse that we always recite after every lesson, Allah SWT says, A'udzubillahi minasyaitonirrajim, innal insana lafi khusrin. Indeed, mankind ataupun manusia itu lafi are verily indeed they are in khusr, which is in a total loss. So kalau loss ni in terms of efficiency, maksud dia apa? Output is less than the input, betul tak? So if the efficiency ratio is less than 1, that means kita rugi. That means kita loss lah, khusr, kerugian ni. So maksud dia apa? We tend to become in loss because our output is not comparable with our input. Input yang Allah SWT bagi kepada kita, abundance, multitude, levels, banyak sangat, uncountable. Even being able to understand the subject matter in physics is actually a ni'mah by Allah SWT, betul? Being able to utilize our brain in order to brain the chapter on electric field, in order to perceive life, in order to perceive waves and superposition and whatnot, that is actually a favor by Allah SWT to us. But at the end of the day, if the output is not comparable, we will be in loss. It won't be efficient. We as a system of mankind will not be efficient enough. because our output or apa orang Melayu kata tak setara lah kan. Dia tak sama. Kalau sama, kalau output sama dengan input, okay, tak ada masalah. Kalau output lebih, that's what we want lah kan, the ratio. So let's reflect on these two verses with the principle of conservation of energy. Okay. Maknanya apa? Allah SWT has given us abundance of favors. Have we produced an efficient output out of all of the ni'mah that Allah SWT has given to us? This we need to answer. If we do not answer now, surely in the hereafter, in Yawmul Mashhar, pada Mahsyar nanti kita akan menjawab. Allah SWT will be asking us, so I have given to you 2 legs, what have you done with it? Allah, I have given to you 2 perfect eyes. And sometimes ada setengah orang tu dia dapat 4 mata, betul tak? 2 mata cuma mata. So you got 4 eyes. So what do you do with it? You've got 2 hands, what do you do with it? Those are actually the very small ni'mah, and they are very big ni'mah. Contohnya apa? You are given the religion of Islam. What do you do with it? Do you just waste the time that has been given to you? What do you spend with that time? Is the output useful or is it useless? Again, the energy output from all of the inputs that I have been given to you, have you been using it to the useful path or is it to the useless path? If it is useless, then we know what is the... Kalau benda-benda yang tak efficient, kalau kita ada electrical appliances, what do we do actually with all those inefficient electrical appliances? We check it out kan, buang je lah kan benda yang tak efficient. Kalau ini kan, buang lah kan. But as an engineer, we try to fix it. We try to fix it, make it more efficient. Contohnya, kalau aircon mula tak efficient, kita buka lama-lama tak sejuk. There must be something wrong. So kita buka tu, kita bersihkan, at least kan, kita bersihkan dia punya habuk-habuk, betul tak? Because habuk tu, dia akan menyebabkan the process, cair freon and whatnot tu kan, akan menyebabkan the process of conditioning the air gets slower. So as engineers, we try to fix the situation. We try to fix the system in order for it to be more efficient. So that is actually what we have to do. Kan? We, mankind, insan, as a system, have to fix ourselves in order to ensure that our energy output are only useful. And we have to minimize. We cannot eliminate it straight away, but we can minimize the useless energy output that is unwanted by Allah Subhanahu Wa Ta'ala. So what is the best way is actually to define what is the useful energy output that is desired by Allah Subhanahu Wa Ta'ala. So that's it for now, insyaAllah, for the bonus leg as well as chapter 10. So you will be doing your test, insyaAllah, tomorrow on the 1st of Ramadan. Hopefully everything goes well. So if you have any other questions, you can ask in the Telegram, or you can always contact me directly. So insyaAllah, now it's raining here in Bandar Baru Bangi. Hopefully this is the blessed rain. Allahumma sayyiban nafi'an. InsyaAllah. Aqulu qawli hadha wa astaghfirullah li wa lakum. See you guys. The earliest will be on Monday for the review on the quiz that you'll be answering tomorrow. And have a happy Ramadan, month of Ramadan. Send my regards to your parents. And just mention to them I've said hi and happy Ramadan as well, insyaAllah. Wallahu a'lam bishawab. Kita tangguh dengan tasbih kafarah surah Al-Asri. Bismillahirrahmanirrahim. Subhanakallahumma wa bihamdik asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asri innal insana lafi khusrin illa alladhina amanu wa 'amilus solihat wa tawassaw bil haqq wa tawassaw bis sabr. Alhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.